Hey everyone, and welcome back to Newegg TV. My name is Paul, and once again we have a special guest in the Newegg TV studios. This is JJ. You guys would probably recognize him from some of our other videos, but JJ, thanks for stopping by today.
Thanks for having me.
And what we're here to talk about is this sort of outside-of-the-box build we have, and specifically about Thunderbolt.
Yes, correct.
And let's just start from the basics. What is Thunderbolt?
Well, Thunderbolt is an entirely new interconnect. I mean, we're always really interested about trying to bring the newest standards in terms of the PC industry to the motherboard, right? And to be able to provide more flexibility and connectivity. But the reality is that there's not actually that many new standards that come upon us, right? I mean, USB, eSATA, a FireWire, network ports, all those things have kind of been around for a while in terms of the connectivity standards. And over the last couple of generations, we've seen kind of jumps in terms of, let's say, improvements in speed and performance, and functionality more or less has kind of stayed the same. We've seen a couple of different changes over the last couple of generations with now going over to like USB 3, eSATA, 6G, giving us more throughput, more flexibility, but Thunderbolt is really an entirely new kind of interconnect in terms of its approach. It's really been designed from the ground up to be able to take a lot of the advanced throughput that's offered on the internal PCI Express bus, but be able to provide it to you externally. And that's actually what the Thunderbolt controller is. It's actually a tunnel implementation that's effectively taking PCI Express and the DisplayPort signal, transmitting it from an internal link on the board to actually the external cabling system, and then allowing you to have essentially those externally enabled PCIe enabled devices. And the endpoint being a high amount of throughput, for one, two, being able to transmit power, 3, an optimization for audio and video, where you have advanced synchronization and timing and low latency. And then 4 is going to be aggregated performance that also kind of works in conjunction with daisy chaining, so that you have the ability to not only have multiple Thunderbolt devices connected to each other, but in that you can aggregate functionality. And so what I mean by that is you could imagine having, let's say, a Thunderbolt-enabled monitor. And that monitor could actually have, let's say, like a USB port on it. It could have a PCIe network port on it. It could even have wireless connected onto it. And all you would have to do is, let's say, connect that Thunderbolt header, the Thunderbolt connection to the header on the motherboard, and then you make that cable connection to the monitor, and that monitor then would have all those ports be enabled on it with no other connections.
So if I've never used Thunderbolt, or I think Thunderbolt is just something that Apple has, essentially you're going to be able to take external devices, plug them into your computer, but not just in the typical way that you might plug in an external hard drive or something like that right now, but it actually has enhanced throughput, also a lot of additional features aside from just plugging a single device in.
That's correct. I mean, at the same time, though, we do want to help to communicate that the functionality that you're going to have from it is going to be very similar to the same connections that you have. And actually, in a couple of ways, there are some nice improvements, right? With Thunderbolt natively, it is essentially a plug-and-play solution because it works directly at seeing the PCI Express bus directly. And in that respect, it's different than like USB 3, where you actually have to have a driver to actually have it operate correctly. So in that regard, you don't need to do that. Now, there are going to be certain situations down the road where you're going to need to have a driver installed to potentially have the best functionality. So things maybe like hot plug or things along those lines to work correctly are going to require a driver depending on the device. But in some respects, it's actually even more plug and play than other devices. And in terms of the power protocol transmission, that's pretty straightforward. Your host bus device, in terms of the board, this is required to be able to drive up to 15 watts. Okay, and then your endpoint device, so if we go over to your side of the table here, we have 2 endpoint devices. So here this is a LaCie little big disk, and it's got 2 ports on it. This has to maintain daisy chain and putting power back out, okay? And this would be a single point device, which can receive a maximum of 10 watts.
And daisy chaining, for those folks who might not be familiar with it, is the ability to, say, route Thunderbolt cable from your computer over to this device, and then actually you can link another device off of that. And actually
correct, yeah. So we could take this Thunderbolt cable here, connect it to to one of these ports here, and then run the other secondary output to this actual drive right here.
Very nice.
So that gives, I think, a little bit of context, but overall it's a really, really impressive spec, and part of the thing that we want to do is just kind of show some of the functionality and versatility that you have. So first and foremost, let's talk a little bit, I guess, about the configuration that we have set up here.
Yes, it's a bit all over the place, but we do have essentially a computer set up here on the table. We're using an 850 watt power supply. We have the newest ASUS Z77 board, the P8Z77 Premium. We've got, of course, the Corsair Dominator memory installed. We have, is this a, which CPU?
3770K.
3070K CPU. And then one of the great features of this new board is that you actually have the Thunderbolt header directly integrated onto the board.
Yep, and in case anybody's wondering, they probably don't see any SSDs. We are using the an actual 120 gig mSATA drive on the motherboard as far as running the operating system, in case anybody kind of catches that we don't have anything connected there. Now, in terms of the configuration, it's pretty straightforward. So we have here the Thunderbolt connection on the native header on the board, and then we're running out to one of these LaCie little big discs, okay? And then we're now receiving an input here on this end, and then we're taking a mini DP cable, plugging it into here, and then that DisplayPort cable is then being plugged in here to our monitor. So that's also showing you one of the really cool benefits of the Thunderbolt protocol, is that we're able to carry both the PCI Express or the storage signal, as well as we're also able to pass through the DisplayPort signal. And that's going to be for both audio and video and high resolution. So while this panel is actually only limited to, let's say, 1080p, our upcoming PAV panels that are going to support QHD, so like 2560, would also be able to be driven without any problems. And you could simultaneously be utilizing them because you have upstream and downstream 10 gigabits throughput. So it's a very robust implementation that gives you a lot of flexibility.
And just to clarify, for folks who are looking at the connector, the Thunderbolt connector specifically, it is a physically mini DisplayPort connector, but then you actually need the Thunderbolt cable to run to a Thunderbolt-enabled device, but also it is backwards compatible in some respects that you can still feed a DisplayPort video signal out of that.
Yes, yeah. So there are a couple of kind of some tricky considerations to take in mind. So one, the easiest way is that if we can get in here on this actual cable, you'll see that there's a little lightning bolt. This is the actual kind of universal logo here for the Thunderbolt standard. Okay, so that lets you know that you're dealing with a Thunderbolt cable. If you were to look at a mini DP cable, it would have like a little square box with 2 lines on the sides. And that's letting you know that's a display output cable. Now, one thing that people might be wondering about is kind of this fat kind of like a little portion right here on the cable. That's because there's an active processor in there. There's actually IC logic. There's a circuit in there that's designed to help to amplify the actual signal and maintain the high throughput and performance that's needed for the high specification speed that Thunderbolt works at. Now, there are 2 different operating standards for Thunderbolt. An optical standard that can not transmit power, but has a longer reach of up to 50 meters. Okay. Then your secondary, which is this is the electrical standard, goes up to 3 meters and can transmit up to, like I said, the 15 watts in terms of the power. So this is really currently the most common Thunderbolt connection you're going to see on the market for the majority of the devices. But you could expect to later on see, of course, the optical standard depending on the usage model that's required.
So with this standard, similar to, say, plugging in an external USB mini hard drive, you get both the power and the data on the same connector. So you're going to plug something in, it's going to be able to get power.
Correct, yeah, and you don't need to do anything in addition. Now, in terms of the connection, if we move back over to the motherboard here, the motherboard has the ability to transmit the DisplayPort signal or the Thunderbolt signal. So if we were to connect that mini DP cable, right, to this, that would output fine to our monitor. If we wanted to connect a mini DP cable on both ends from here to a Thunderbolt device, that would not work.
Okay.
Because that's not Thunderbolt in terms of actually at the transmission. Okay.
It's only going to be able to carry the DisplayPort.
Exactly. So the way that you want to think about it is that if you're involving a display, you have to use the DisplayPort cable. Now, the only time that would change is if you had a Thunderbolt-enabled monitor. But currently in the PC ecosystem, there are not currently any Thunderbolt monitors. But there is eventually the potential that you could have that one cable also connect to a monitor.
And that's the situation you're talking about where you might have a monitor with additional ports on it or additional features like Wi-Fi.
Yeah, essentially you could think anything that's PCI Express could be incorporated on that other end. And while we're showing you storage devices in terms of the future of what Thunderbolt is going to have, especially for the content creation guys, there's a lot of really interesting devices that are maybe actual capture devices for audio and for video that are done real time that you could directly connect. You could even have maybe PCI-enabled graphics subsystems that could be done through Thunderbolt. So it's a very interesting specification in that. So with that, let's take a look in terms of how hot plug is going to work, because it is something that you have usable here. So as we noted here, we have our panel set up, right? So that's DisplayPort coming into mini DP here, and then Thunderbolt going from here onto the board. And so then we've got a couple of other disks here. So let's go ahead and connect these disks, and we'll get this started here.
Okay.
So we're going to go ahead and disconnect the DisplayPort monitor, and we're still now connected to the little big disk, but we're going to take this cable here and connect the next drive. And then if you want to hand me that one, go ahead.
I'll do 4.
Add that one to the mix there.
Okay.
Okay, so you can see there now all the drives have been initialized. Our panel came back on, so we've now actively hot plugged those successfully. And you can already see here that hot plug is working correctly. All my other drives have now shown up without any problems there.
It's a lot of autoplay.
So at this point, what we're going to go ahead and do is actually going to show you what the maximum performance potential is in terms of Thunderbolt. For a little bit of context, though, for some of you guys that are interested in this, just from an entry-level enthusiast standpoint, maybe you're just somebody that's looking for a really flexible kind of high-performance external device, and maybe USB 3 isn't maybe even fast enough for you, or maybe you're doing basic content production work, you know, audio and video, maybe an external scratch disk, different things like that. You might be interested in Thunderbolt from a more simplified solution. I do want to kind of make it aware that from a cost standpoint, some of the Thunderbolt devices that have been focused on are very expensive, and they're very, very high performing, but you could be easily talking over $1,000 for some of the advanced kind of Thunderbolt storage RAID arrays. Here we're using a Seagate GoFlex. This is actually only about $100, so it's pretty reasonable in terms of the cost. You could then pair it with any high performance SSD and have an immediate high performance storage solution available to you that you know, from the performance numbers that I showed you already, you can actually have quite a bit of a jump in terms of performance. So let's take a look here quickly at USB 3 and then Thunderbolt. So this is just with a single drive. And we can see here that on the left-hand side, we have a maximum read rate throughput of about 290 megabytes and read at about 259 megabytes. Okay, and then on the Thunderbolt side of the fence, 351 and 382. So quite a bit of an increase in performance. And the other thing that this benchmark doesn't come out to tell you is that there is also a significant advantage in queue depth performance for Thunderbolt, is that it natively understands multiple read and write commands, as well as has those optimizations for audio and video, which aren't present in the USB bus protocol. So while USB might potentially be able to understand more commands if you were to shift it into like a USP operating mode, that's not going to be as prevalent because it's going to require hardware that does support that. ASUS, of course, does support that technology in terms of our USB 3 boost package, but across the industry, Thunderbolt is going to be a natively faster solution with also faster, higher maximum throughput than the 5 gigabits that's going to be offered on the USB 3 bus compared to the 10 gigabits performance that's going to be offered on Thunderbolt.
And QDEP support is one of those things where if you are not just talking about data transfer to like an
but in the way that you use it, right?
But actually if you want to have a drive plugged in that you're running a program off of, or like you said, using as a scratch disk, something like that.
Yeah, or you're running active workflow, or even if you're doing multiple read and write commands to the disk, then it's going to be quite a bit more robust to have the extended QDEP support.
Okay.
So from here, we're going to go ahead and take a look at our drives in terms of now all the drives that we have available to it. And we're going to run a software RAID to go ahead and aggregate the performance on this. We'll let it format, and then we'll come back to taking a look and see what the Thunderbolt performance looks like.
So we have the software RAID set up right now, and we're running Atto.
Yeah, and as we can see right here, it's not yet completed, but we've already broken past what the actual throughput barrier is offered on USB 3, where you can see right here, we're here 791 megabytes and 517 megabytes on the write performance. So already outstanding performance. And the cool part of this altogether is, once again, is that we are maintaining the actual DisplayPort signal being passed through. So this can all be done simultaneously. Well, if let's say you were still even watching video, you were doing a preview, you could be gaming and doing a full real-time backup, and you wouldn't have it be compromising or hampering performance. So it's a really robust solution that also you can see just in terms of the maximum throughput is really impressive. I mean, right here, we're starting to get close to the saturation point. There's still actually definitely some headroom left, and there's going to still continue to actually even be further optimization within the architecture, because we're dealing actually with some limitations in the controller logic inside of these drives themselves. These drives themselves aren't really tuned to the extent of being able to really take advantage of high-speed storage as well as the Thunderbolt interconnect. So with more advanced enclosures that are coming to the market, as well as continue to be produced down the road as we take a further and further look at Thunderbolt, you're going to get pretty impressive performance markers. But we can see here that we took a look at the maximum performance offered here in our configuration with a queue depth of 10, really showing the high functionality in terms of extended support for multiple queues. And our peak read performance was 907 megabytes, and our peak write performance was 625 megabytes. So overall, when you compare that to the USB 3 specification, you can see that it's offering significantly higher throughput, as well as offering much more robustfulness in terms of the connectivity functionality.
Now, since we do have multiple devices as well as a monitor, all daisy-chained off of the single connector, is there any concerns as far as bandwidth availability, like when you're running multiple devices?
No, because like I said, there's a dedicated mandatory link. Now, there will be different implementations that come to the market, but with our premium board, we have a dedicated by4 PCI Express link specifically for the Thunderbolt controller that maintains activeness. So at that point, we're always ensured that bandwidth is always there. And that's part of the kind of the benefit of Thunderbolt, is that you can always be able to maintain that performance.
All right, so does that conclude our lesson?
I think that overall gives us a little bit of breakdown of some of the really cool aspects in terms of Thunderbolt and the performance benefits. I think that we're going to show them also in a separate video, actually the functionality you can have with Virtuo and Thunderbolt and still being able to run a discrete part.
Very nice. So that's going to wrap it up for this video, guys. Once again, this has been the ASUS P8Z77-V Premium Motherboard. We've been featuring the Thunderbolt connectivity, running all these LaCie drives, and there you have it. We've been running both the display as well as all the drives off of the single connector. So a lot still to come with Thunderbolt. But want to say thanks again to JJ for stopping by and sharing all this information with us.
Thank you for having me, like always.
And to all of you, thank you very much for watching. If you'd like to see more, you can check out our Newegg YouTube channel. If you want to see more of JJ, you can head over to the ASUS ROG channel. They have more videos over there. See y'all next time on Newegg TV.